Here we go. Notes 15. By the way, we are done with rotary motion. So we're going to have a quiz on Friday. Relax. It's going to be an easy quiz. As a matter of fact, I'm already telling you in advance what one of the questions is going to look like. Remember the bike question from the notes? Okay, that one's in there. I just changed the numbers, literally. So the bike question's in there, and then one other question, which I'm not going to tell you that one because then I'd give you the whole quiz already, and all you have. But it's only going to be 2 questions, ABC. It's a short quiz, 1 pager, back and forth, back and front. So it shouldn't take you the whole period. It'll be on Friday. How long is classes on Friday? 40 minutes. If you know what you're doing, like if you really know what you're doing, you'll get it done like in 10 minutes. If you don't know what you're doing, it might take you. If you kind of know what you're doing, then you'll do it between 15 and 20 minutes. And if you don't know what you're doing, well, you can take forever, right? Because you don't know what you're doing. But if you know what you're doing, 10 minutes in and out, because you just go right through each one. Two. What's up? Yeah, rotary motion. Not this. This is even easier than that. But I don't. Then if I start giving you a lot of subtopics, then it's called a test. A quiz is just that little subtopic. You know what I mean? Delta mass doesn't have rotary motion. Yeah, I think you guys have been doing the homework. I think you guys are good. I passed back your rotary motion activity 1. I'm grading your rotary motion activity 2. I guess if you swing by after school today, or maybe if I already graded it, I have some here that I already graded. I can give it back to you. Oh, look, Ms. Miller. Oh, no, she's not here. I was about to say, Ms. Miller already graded yours, but I haven't. But she's not here yet. So come by after school, and I guess just wait a little bit so I can grade it and give it back to you if you want it. All right. So what are we doing today? Objective: derive a component argument property expressing cosine A minus B in terms of cosine and sines of A and B, and use it to express a linear combination of cosines and sine as a single cosine with a phase displacement. Chop, I have no idea what you just read. Can you tell me this in plain English? Well, that is English, but okay. So all I'm trying to tell you is that I have a combination. So that means I'm adding 2 waves. So I have something like cosine theta plus sine theta. And I'm turning these 2 waves. See how there's 2 components? I'm turning these 2 waves into 1 wave. A cosine theta minus D. That's all you're doing. So you're turning 2 waves into 1. Chop, when am I ever going to use this ever in my life? Well, if you become an engineer and you have 2 different signals, isn't it easier to analyze 1 signal than 2? If you're in music, maybe this is a tone and there's another tone, and when you add those 2 tones together, you can create 1 singular tone that mimics the same as those 2 tones combined. See? So there's many applications, not just engineering, but you can see the applications are there. You know that whenever you pluck a string, it has a frequency, right? Okay, so there it is. So it's just 2 signals that you're combining together. Of course, we're talking about simple signals here, right? We're talking about simple a cosine and a sine, and you're adding them together, and we're creating 1 single cosine with a phase displacement. So we're just turning a linear combination of cosine and sine into 1 single cosine. That's all. Cool or not cool? Okay, and we're gonna do a hack. Chav, what do you mean a hack? Well, let me show you. It says the expression y equals negative a cosine theta plus 3 sine theta is a sinusoid that you can express in the form, so that's what we want, where a is the amplitude and d is the phase displacement for y equals cosine x. Yeah, maybe. Okay, well, y equals a. Well, that's fine. Let's talk about this cosine. All right, you guys ready? We're going to go slow. Let's see if we can transform that same equation, that same expression, as a single cosine with a phase displacement. So here's your hack. You guys have been doing physics, right? Have you guys done two-dimensional motion? Like you find the velocity in the x direction by using cosine, and you find the velocity in the y direction by using sine? Okay, it's kind of like the same thing. You see this? I guess I'll write it here. Well, yeah, I'll write it. I already started writing it. You see this negative 8? It's in front of cosine, so we're going to use this, and we're going to say that negative 8 is like an x value, because cosine is for x directional motion usually, right? And then that sine, and I wrote sine theta instead of sine x, so you want to keep the arguments the same. That sine that 3 is in front of sine, so that 3 is like a y value. So here's our hack. I'm going to plot the coordinate negative 8, comma 3. So I'm going to exaggerate quadrant 2. Negative 8, comma 3 point. I'm going to create a reference triangle. This A that you see right here in front of the cosine is going to be this A right there. The angle I want, the theta I want, or I guess if I'm being specific, the phase displacement, the D here, the angle D. If I want angle D is this guy right there. That's angle D. So that's the hack that I'm going to use. So first, how do I get A? Well, that's just Pythagorean theorem. This is negative 8. This is 3. So I can say A equals, or A squared. You know what? I'll just do Pythagorean theorem the way we usually do it. I don't want to confuse you guys. Negative 8 squared plus 3 squared equals A squared. Do you guys agree? Negative 8 squared is 64. 3 squared is 9. And that still equals A squared. Notice I'm going slow, guys. I listen to you guys. I listen to you guys all the time. When I add those two numbers up, I get 73. But I don't want A squared. I just want A. So A is just the square root of? Perfect. So I got my A in the A cosine theta minus D. Now I need angle D. So here's, okay, there's many, okay, let's go slow, guys. Time out. I need you guys to focus. Focus, Lizardi. There are many ways to get angle D, but I think the easiest way, here's what I think of the easiest way for you guys, is to find a reference angle right here. And then from finding the reference angle, you can find angle D. Does that make sense? And I think you guys, what do you guys like better, degrees or radians? Okay, so let's go ahead and change our calculator to degree mode. Mode, degree. I am going to do at least one in radian, but I'll do the radian one last. So right now I'm in degree mode. Are we okay? All right, so here we go. I'm going to get angle, I'm going to get my reference angle, theta r. So I like to go right to it and just, you know what? No. I need to do it with the way you guys know. All right, right SOHCAHTOA. Is the reference angle ever negative? So you're not going to have any negatives for your numbers, for your reference. So here's what you're going to do. We're going to use tangent. You can actually use sine and cosine, but the formulas down there have tangent. But maybe in a little bit, we'll poll you guys and see if you guys want to use sine or cosine. So I'm going to write this. I'm going to write sine theta r equals opposite 3 over adjacent 8. Why did I not put a negative in my 8? Yeah, reference angles are never negative. If I would have made that 8 a negative, and why did I write sine? I just said tan. How come you guys didn't correct me? Tan, yeah. It's tan is opposite over adjacent, guys. So that was a big error on mine. If I would have put a negative 8 and I would have done arctan, I would have gotten a negative angle. Do you guys know what I mean? It would have given me a correct angle 4 in quadrant 4, but then I would have to adjust and add 180. It's fine. It doesn't matter how you do it, guys, as long as you know what you're doing, using correct logic. Don't be a robot. Are we okay? All right, so here we go. How do I get theta r by itself? Arctan or inverse tan. Either or are correct, but make sure you say the word inverse or arc. So I take my calculator and I'm going to go arctan, make sure you're in degree mode, of 3 divided by 8. And I got 20.556. The more digits you can put, the better. 20.556. And put a degree because that's a degree. Now, okay, I'll slow down. I'm slowing down, guys. Theta r, my reference theta, my reference angle, I do want it. But I don't want that angle. I want angle D. Do you guys see that? So, subtract it from 180 because this angle in blue is 180. And I subtract my reference angle to get angle D. Do you guys see that? So I'm going to write angle D is equal to 180 degrees minus 20.556 degrees. And let's see what that is. So I take my calculator and I go 180 minus, and I'm going to subtract this number here. And then there it is, 159.444395. So I'm going to write 159.44395. The more decimals you put, the more digits you put, the better. 159.44395. Yep, there it is. So that means that this expression should be the same as y equals square root of 73 cosine, open parenthesis, theta minus 159.44395 degrees, close. That's my hack. This is why I told you that this was going to be the hack. A is the amplitude of your cosine graph. So I created this reference triangle to find my A. Like that's a hack. That's a relationship. You know what I mean? Like that's the hack of how we get the amplitude in front of that cosine. All right. To answer the question, how do we know that this really is what we say it is? Don't just take my advice. Well, I mean, I would like for you to take but always question like, well, how do I know? Like just like Miss Houston said, how do I know that A is the amplitude of that single cosine? Well, let's see. I'm going to take my calculator and I'm going to type the original expression in y1. Yes, I would. Negative 8 cosine x, close parenthesis, plus, was it 3 sine x? Or 3 sine theta? Okay, so there it is. There's my y1. And go to y2, and I'm going to go square root of, what was it, 73? And then get out of the square root and write cosine, and then x minus, and I already forgot. Oh, you know what? I got a cool hack for you. Second quit. You see this number? Instead of typing it, just push enter, and then push STO, S-T-O, and then guess what letter I'm going to use? D, yeah. Alpha D. Good job, Miss Houston. Bam. Because that is the angle D. Isn't that cool? Yep. Now you can, the graph and the home screen communicate with each other, and now we can just put angle D. Isn't that cool, guys? Yep. Yep. Yeah, check it out. Yep. Look, there it is, 159.44. And so here, how did I do it? I just pushed enter on this guy. You can also push answer, second answer, and then the store button, and then alpha D. So now every time I push the answer D or the letter D, bam, see, I have the answer right there. All right, check it out, guys. If you push graph, you're just gonna see this. Like, what is that? Like, you can't see the wave. Chavez, it's supposed to be a wave. Well, remember, we changed it to degree mode. Mode 0, x min, x max. Let's see. Let's put 720. 360 plus 360. X scale, I don't know, maybe go by 30. Y min, negative 10 and 10. Yeah, that's fine because square root of 100 is 10. So we're at square root of 73, so it's going to be in there. Push graph. And look, oh man, it went so fast. I have a fast calculator here. Okay, look, let me turn off the red one. Look, here it is. Here's Y1. Here's the original. Do you guys see that? Now let me turn on Y2. Y2's red. And let's see if it goes over the same curve. Look at this. It's going to go fast, guys. And look at that. It's the same. If I look at a table, let's look at a table. Look at those numbers. They're the exact same. Well, you know what's happening, right? It's the exact same, but notice that the very last digits are a little off. And I know why that's happening. Because you see this right here? This number actually goes on forever. But it's cutting it at 8. I bet you if I would have done, let's see, it's not gonna do it anymore. Okay, let me type this in. If I would have done this, and then I would have gone 180 minus this number, and you don't have, oh no, I gotta push answer. Gotta push answer to get the number in the register. Minus answer, and now I'll get that number, and if I go store, now it's storing all the strings into D here. And now let's see if it works. So now the angle D is already there, and now let's see if it's perfect like I wanted it. It's still off a little bit. So there's the very last digit is being off. That 4 and 2, it's a little off, but you can tell it's the same number. Maybe there's some tolerance that I don't know about from this calculator, but it's the same. Do you guys see how it's the same? Isn't that cool? Oh, you guys are not impressed? All right. Here are the formulas. I don't want you to become a robot. Can you do this being a robot? Probably. I've had students trick me into thinking that they know it, and then when I probe them, they're like, I don't know. I just see that's how you do it, so I copy what you do. Guys, I want you to use logic. Yes, you can do math being a robot, and you can probably trick some teachers. You can probably trick me, but I want you to know the logic of why it is what we do. What we do. We're using this hack here. What's up?
The formula A equals square root of B squared plus C squared. That's technically a Pythagorean theorem.
Yeah, that is Pythagorean theorem. If you were to get a squared, because I think in physics you guys do a good job of like isolating variables. If you were to call this B and C, that is, and you were to get a by itself, square root, that is Pythagorean theorem. A equals square root of B squared plus C squared. Cool. All right, we're gonna do some more. I read a book a long time ago about about pedagogy, the way the brain works, and to not go too far into what the way, like, not to talk too technical, but what the book pretty much said, and you had to read well, it doesn't matter how long you have to read, but what the book pretty much said in essence is if you do something 3 times, it becomes like you kind of know it. So if you notice, I like to put like 3 examples, and after you do 3, usually you're like, okay, I got it now. So 3 is like a magic number. I don't know. Did you guys want to know that? Maybe you did. Maybe you didn't. All right. So do you guys want to continue in degree mode? Okay. Well, for one more, because this one's a pretty simple one, 4 and 3, and then for this one that's a little harder, we'll do this one in radian mode. So let's continue doing this one in degree mode. So let's do our hack. So here's my hack. That 4 is like an x because it's in front of the cosine. That 3 is like a y because it's in front of the sine. Cool or not cool? Then I'm going to draw quadrant 1. And it's not to scale. I'm going to say 4, 3. I'm going to say this point is 4, 3. I'm going to connect it to the origin. I'm going to say this hypotenuse is like the amplitude that I want for my cosine graph. And this angle, while it is a reference angle, but because I'm in quadrant 1, that is also angle D. We're still okay?
So angle D varies depending on what quadrant you're in.
Well,
so that's like for the last one, it was in the second quadrant.
Yeah, right? So I wanted this angle. But I'm in quadrant 1, so it's just, yeah. All right.
So that's why it's inside the triangle.
Yes. Because the reference angle is going to be angle D anyways. All right, here we go. What's up? What's up, Houston? You're not going to subtract anything because you're in quadrant 1. So, yeah. All right, here we go, guys. Here we go. I'm going to find my A first. Is it okay if I just go A equals the square root of 4 squared plus 3 squared? Which 4 squared is 16, 3 squared is 9. And I don't know, maybe some of you probably are like, Chab, why are you doing that? It's a 3, 4, 5 triangle. Well, I'm showing everyone else. So A is 5. Are we still okay? All right, here we go. I'm going to find my angle. So I'm going to write angle D is equal to, this one is going to go arctan, and opposite over adjacent, so SOHCAHTOA. So this is 3 and this is 4. So arctan of 3/4. So I take my calculator and I'm going to go arctan, so I can quit. Arctan of 3/4. And there it is. That's my angle, 36.8698. 36.8698. Put a degree symbol because we're working with degrees. If you do not put a degree symbol, then it is considered a radian. Yeah, it's considered a radian if you don't put a degree symbol. So there's my angle D. And there it is, guys. I got everything. So I'm going to write y equals 5 cosine parenthesis theta minus 36.8698 degrees. Close it. I hope I put a degree in the first one. Yeah, I did. All right, let's check it. I'm going to check it. Here's my calculator. I'm going to go to y equals. I'm going to clear y1 and y2. Oh, I haven't put angle D in there, so let me go to my home screen. So you see this guy? I'm going to push store angle D. So there's my angle D. I go to y equals again, and I'm going to type, was it 3 cosine or 4 cosine?
It was 5 cosine.
Oh, no, but the original.
It was 4 cosine.
4 cosine x plus 3 sine x. All right, and now here comes 5 cosine x minus alpha d. I guess you can type the number if you want, but this is better because it's everything. So let's see if it matches. I'm going to push graph, and look at that. Perfect. Cool, right? Yay. Okay. Can you show you what? Well, mine's a computer, so it's going to do it fast anyways. But this trace step, this tells you how often, like, to put a little dot. So you'd have to mess with that, but I wouldn't mess with it. Okay, well then turn the trace step into a bigger number, because that means it doesn't. It won't, like, you know what I mean? Like, it just if you put it into a smaller number, then it puts every. Well, what is it at right now? 0.1. So maybe turn it into a 1. But remember, the bigger the number you make, the less accurate the graph is going to look, right? It might look like lines instead of a nice little curve. So let's see, did it work? So if you compare this and that one, this one's way faster. So, okay. Now that we covered that, all right. So we got one last one. I'm gonna do this one in radians because I want you to experience radians. So I'm gonna change my mode to radians. You don't have to if you don't want to. Like, Chop, I want to do all these in degrees. That's fine. But I would like for you guys to get experience with radians as well. You know what I mean? So here I am. I'm converting it to radians. Okay. So first thing first, I'm gonna do a sketch. Here's my hack. Hack. Ready for the hack? That 15 or negative 15 is in front of the cosine, so that's like a x. That 8 is in front of the sine, so that's like a y. So I draw my little quadrant 2. Whoa, what was that? Yeah, it sounded like someone fell too. Negative 15, 8. Here's the point. I'm going to pray for them. I hope that they're doing okay. Amen. Okay. I hope. Wait, I hope. No, I hope. No. Not I hope. I want them to be okay. Amen. Okay. Hallelujah. Okay. I'm going to heaven, guys. All right, here it is. Here's your amplitude. All right, guys, let's focus. Maybe it was my fault. Let's focus, guys. Let's focus. Here's negative 15. Here's 8. Let's already focus, miss. Are we still okay? All right, here we go. A equals the square root, parenthesis, negative 15 squared plus 8 squared. If you already know something's being squared, okay, side note real fast. I think we can do this in less than 30 seconds. Guys, if you put a negative 15 squared like this, know that it should be positive. But why does this give me a negative? No, well, it's
only squaring the 15.
Yeah, it thinks you're doing this. It thinks you're doing negative, and it's only squaring the 15. This, for those of you that are in computer science, this is just programming. This is just code. You're telling the calculator that whatever this number is to force it to be negative. This is how code works. So if you want it to be, so if you have negative 15, you do parentheses, negative 15, and then you square it. And then that will be 225. Do you guys see? So that's just something for you guys to know. All right, square root. Actually, let's find out what 15 squared plus, what is it? I already forgot. 15 squared plus 8 squared. Is that a perfect? Yeah, it is. It sounds like one of the Pythagorean triplets there. What's the square root of 289? 17. Yeah, that's one of the special triangles, like the 3, 4, 5, and all that good stuff. Oh yeah. So here we go. So this is 17. So there's my amplitude. Now I need my angle. So what am I going to do? I'm in quadrant 2. I'm going to find the reference first. And remember, I'm in radians. And whenever I find my reference, I'm going to subtract it. But not from 180. I'm going to subtract it from, not 2 pi, pi. Because the distance from here to here, that's pi. Do you guys see that? Okay, so here it is in green. Theta r equals arctan of 8 over 15. Don't put the negative because this is reference. I just went right into it, guys. And I'm gonna say what that angle is. And remember, I'm in radians, so it's gonna be decimal. Arctan of 8 over 15. I got 0.489957. 0.489957. Hopefully I wrote that right. So here it is. Angle D, which is this angle right here. That's angle D. Angle D is pi minus, so hopefully now you're seeing where when we do arc sine, the pi minus whatever comes, minus 0.489957. I'm just going to tell the calculator to do it for me. So I go to my calculator and I go pi minus this answer, and I get 2.65. 2.65, and I need more digits. Some of you just put 2. 651635. The more digits is better. 651635. 651635. Did I say that right? Okay. So there it is. So my new equation is going to be y equals 17 cosine. It's not a degree. Theta minus 2.651635. Don't put the degree symbol. If you put the degree symbol, it's a degree. So there it is. Take your calculator. Now, remember, I'm in radian mode. Y equals, I'm going to clear Y1 and Y2. And give me the original. Negative 15 cosine x plus 8 sine theta. That's 8 sine x. Okay, so there's Y1. Here's my Y2. Here's the new one. It's a single cosine. What was it? 17? 17 cosine x. Oh, did I ever store it to angle D? I didn't, right? Nope. Store alpha D. I guess you can also type it in, but I'm being lazy here. Go back to Y equals x minus alpha D. And don't push graph because remember, we had big scales. Window 0 to 4 pi. Chav, how do you know all these? Well, one revolution is 2 pi, so I just kind of in my head like, oh, 4 pi. The period's 2 pi. You can do it to 2 pi if you want. Chav, how do you know the period's 2 pi? There's nothing in front of the theta. It's a 1. So, okay. X scale by pi over 3 or pi over 6. Y min, how big is this? Oh, that's 17. So I need to go like negative 20 to 20. Negative 20 to 20. And then maybe Y scale by 5. And here we go. Graph. Look, it's same. Cool, right? Hold on. Yes, you can.
So it doesn't matter which one.
No, but well, arc sine, right? Arc cos, yeah. All right, guys. So as you saw, is this super tough? It's not. So you also have a chance to check your work, right? Like you can see how you can check it. So there it is, guys. Let's take care of business, and we're good. You okay with a vaso? Go take a walk. Let's go grab some water. Yeah. Do the activity and whatever you feel most comfortable with. Do you like radians? Do you like degrees? Okay, do it in degrees, but make sure you put the what? The degree symbol. All right, here we go. So objective. So let's see what this says, and then I'll talk to you guys about what it means, or maybe I could have written it better. Derive a composite argument property expressing cosine A minus B in terms of cosines and sines of A and B, and use it to express a linear combination of cosine and sine as a single cosine with a phase displacement. So what does all that mean? It just means that I have two signals that I'm adding, two waves, a cosine and a sine. This is what you call a linear combination of cosine and sine. And I want to turn this into one single cosine with a phase displacement. The phase displacement being the D and the A being amplitude. So this is what we're going to calculate. Calculate, like to create it. And I know what you're saying. You're probably saying, Chav, when am I ever going to do this in real life? Well, if you're an engineer, This could be any, like this could be a tone, or like you pluck a string and it creates this frequency, this wavelength. This could be a different tone, and together those tones, when you combine them, you can create that same tone with one sinusoid. Chav, why is that easier? Because it's easier to analyze one signal than to analyze two separate signals that are coming in that creates that same tone or frequency. Does that make sense, guys? So okay, relax. It's like a puzzle. So I said end like three times already. In the very, very end, what's most important is, do you have the tools necessary to solve whatever problem life gives you? Like, oh, I want to go from this to this. How do I do it? What do I have? Do you know what I mean? So we're gonna do a hack. We're gonna do a hack on how we're gonna transform these two waves, the addition of those two waves. That's a linear combination, and I'm going to turn that into one single cosine wave. Could you turn it into a sine wave? Yes, but cosine wave is easier because remember, cosine has that peak that you can manipulate. So we're going to turn this into a cosine wave with a phase displacement, and they're all going to be, the midline for all of these is going to be on the x-axis, because those are the simple ones that we can do. Cool or not cool? Okay, so let's see if we can transform. Let's see if we can transform negative 8 cosine theta plus 3 sine theta into a single cosine with a phase displacement. All right, so I'm going to write negative 8 cosine theta plus 3 sine theta. Here's my hack. You see that negative 8? It's in front of cosine. So that negative 8 is like a x. Do you guys agree? Because cosine is for x, right? Yeah, this is my hack. I know. So, Chop, tell me about this hack. This 3 is in front of the sine, so I'm going to say that 3 is like a y. So I'm going to take the ordered pair, negative 8, comma 3. Are we still okay? All right, so I'm going to graph this. So I'm going to come over here. I'm going to go negative 8, 3. I'm going to put a point, negative 8, 3. And I'm going to connect it. Are we okay so far? I have a right triangle. This is negative 8. This is 3. This is your amplitude of that wave. Trav, I don't understand how this is connected to that. It's a hack, guys. It's a hack. So it's a way to get these values. Do you know what I mean? The angle D, where's the angle D? This is the angle D. From the positive x-axis to right there. That's angle D. How do we feel? Nothing crazy, right? This is my hack. So let's get the A. It's just Pythagorean theorem. 3 squared plus negative 8 squared equals A squared. Does that make sense? What's 3 squared? 9. What's negative 8 squared? 64. Equals A squared. Are we still all right? What's 64 plus 9? 73 equals A squared. But I don't want A squared. I just want A. What do I do? Square root, square root, square root. A equals square root of 73. Leave it alone. It's not a perfect square root. Now I need to get angle D. And so I'll wait for you guys so I can see you guys writing. Is this making sense? Good. See, it's going to work. All right. So check it out. I want angle D. Sorry, guys. There's my caffeine intake. Okay. Here is angle D, right? Well, that's angle D. I'm going to use the reference angle. You see that angle in green? I'm going to find it. That's a reference angle. Is the reference angle ever negative? No, it's never negative. So when I'm doing my reference angle, you can actually use sine, cosine, or tangent, but because this guy's down here, I'm going to go ahead and use tangent. I'm going to use tangent, opposite over adjacent. So I'm going to go tan of theta r equals opposite over adjacent. Why did I not put a negative in the 8? Why did I put a negative? Because the reference angle is never negative. So make sure you write that down somewhere, that we didn't put a negative, because reference angle is never negative. Reference is never negative. If I would have put a negative in there, my theta r would have been a negative angle. How to get theta r by itself? By doing what? Inverse tan or arctan. Take your calculator. Oh yeah, let me ask you guys. What do you guys like better, degrees or radians? Radians? Oh wow, you guys are actually the first class to say radians. Every other class said degrees. Okay, leave it in radians. I'm gonna go second arctan, and what did I say? 3/8. So 3/8. Enter, and there it is. This is my radian. But remember, this is just that part right there in green. I'm gonna say theta r equals, and then this is the first time I've done it in radians. So 0.35877. 0.35877. Excuse me. And that's a radian. But I don't want theta r. I want angle d. So I'm going to come back. And to get angle d, how do I get angle d? Subtract it from what? Not, if I was in degrees, it'd be 180 from pi. Pi minus 0.35877. That's going to give us angle d. Does that make sense to everyone? Because the distance from, just in case, the distance from, I'll do it here in blue. The distance from here to here is pi. That's pi. So if I subtract the little guy in green, that's going to give me the one in red here, the angle D. Do you guys see that? So I take my calculator, and I'm going to go, and you guys are the first class that says radians. Every other class did it in degrees. Second pi minus, and I go to this guy right here, and there it is. That's my radian in quadrants 2. 2.782821. The more digits, the better. 2.78. Let me do it in red, not blue. 2.78, and I already forgot it. 782821. 2821. Okay, so here's my equation. Y equals square root of 73 cosine, and it says theta minus d. 2.782821. What do you guys think? All right, check it out, guys. How do you check it? Okay, Chav, how do you check it? Like this. You go to y1 or y equals. I'm going to type in the original. What was the original? -8. -8 cosine x, close parenthesis, plus 3 sine x. Was that the original right there, guys? And then on this one, I'm going to type in this guy. Square root of 73 cosine, or get out of the square root, cosine x minus, and what was minus what? 2.782821. 2.782821. 2821. I probably should have used the memory, but that's fine. All right, check it out, guys. I'm going to push window. I'm going to push 0, and I'm going to push 4 pi here. I guess I could have left it as 10, but I'm going to put 4 pi. And I'm going to say, yeah, -10 of 10 is fine because square root of something is between there. So push graph. There's my first one. And look, check it out. There's my second one. Look, I know it went too fast. If you have one of those calculators that don't have color, make it thick. Chop, how do you make it thick? Scroll to the left and push enter one time. And I think it goes to the thick one. Does it? It does? Okay. And you know what? There is a way I can get my. Oh, well, let's not do it because it might be. All right, check it out. I'm going to turn off Y2 because mine did it too fast. There it is in blue. And check it out. I'm going to turn on the red one. And it's going to go real fast over the blue. Bam. Look how fast. Now that one's so fast. I can actually make it slower by making the step size slower. That's fine. Leave it alone. And there it is, guys. What do you guys think? Cool, right? Yay, cool. Okay, let's go to the next one.